So far we've been dealing with pulleys and block and tackles that are flat, sort of like this system where the pulleys and the block and the tackle are sort of next to each other. But in reality they look more stacked like this. So you can see they both have the same IMA, both have the same system here where there's 4 supporting strands, but in this one they're sort of stacked and they look kind of like they're intertwined. But you can see how the rope sort of starts off tied off on the block, and then it runs through the tackle once, and runs through the block again, through the tackle, up back again to your force effort, kind of like over here. But again, this one is used more in real life. So let's go ahead and sketch ourselves a quick example of this system. So we have ourselves a roof, and then, or a block, I guess, and then coming off is, well, we'll have a bar with 2 separate wheels. And let's go ahead and make one bigger and one smaller. And then let's give ourselves a force resistance of, let's say, 200 newtons this time. And attached to that will be a tackle. And let's go ahead and give this one 2 pulleys as well. So we'll go ahead and add one to the top here. And just like we did, we will draw an outer bigger circle here. And let's go ahead and run a cable through it. So we're going to have it go through, of course, starting from our block and running through the first pulley of our tackle, and then going through the first pulley of our block, and then all the way around the second pulley of our tackle. You can kind of see how the system works. It sort of winds around all the way down so that I can pull. I can be off to the side over here, or somebody could. Pulling down. He's a little bit, looks like a giraffe, I guess. He's a little lanky, but let's go ahead and give him his force effort here, which we're going to go ahead and calculate. Now, as we said before, the IMA is the number of supporting strands. Now, let's go ahead and count the number of strands. Well, we have 1, 2, 3, 4, 5. So we have 5 strands in total. But if you look, how many are actually supporting FR? How many are pulling our force resistance up? Well, if you look, well, only these 4 actually hold up our force resistance, or our tackle. So we would say there are 4 supporting strands. Which, of course, is incredibly obvious, just means the IMA equals 4.
And then, of course, assuming an ideal effort force, we can assume the AMA also equals 4.
And of course, we know our equation for our AMA is AMA free, or AMA equals FR over FE. So from there, we can take this equation and say, well, 4 equals FR over FE. Well, FR is just 200 newtons. And then we don't know FE. That's kind of the point here. It's what we're trying to figure out. Well, we're just going to put 4 over 1, and we can cross multiply and divide. 1 times 200 is 200. Divided by 4 is, well, FE equals 50 newtons. And then let's actually write that. Let's say equals FE, and then make this a proper math equation saying therefore. But then let's take this equation to the next level. Let's say we wanted to raise FR. Let's say we wanted to raise it 3 meters. So that would be our distance resistance. How much we raise our weight, or our force resistance. My question to you is, what would DE be then? What would be our distance effort? How much rope would we have to pull on this system? Well, to figure this out, we would have to use our good old IMA equation, our IMA equation. And you might say, well, Mr. Anderson, I thought the equation was equal to the number of supporting strands for IMA. And it is, but it's also still IMA. And so using this equation, we can actually work backwards to find DE and DR using our IMA that we already found using this other formula for a pulley. And so we know the IMA is still 4, that hasn't changed. And we know the DE, well, we don't know the DE, that's what we're trying to find, that's the whole point. We do know the DR is 3 meters. And so, again, I can just put 4 over 1, and I can cross multiply and divide to solve for DE. So 4 times 3 is 12, divided by 1 is 12. So we get DE equals 12 meters. And if you think about it, this makes sense. If I pull down 12 meters of rope, That means to lift this up, I have to pull on an equal amount of each one of these strands. And so this 12 meters is divided into 4, literally. So for example, if we pull up this example, this one's lifting 1 meter by pulling 4. And you can kind of see by watching this video how that actually works. And so hopefully this video helped simplify how mechanical advantage of a pulley works.